Hi, so my name is Alexandra May Hoya, and this is experiment 8 of my data communications laboratory subject. It is entitled Configure Network Devices with SSH. So here, as you can see in our network topology, there is a PCA connected to switch 1 via fast Ethernet 06, and switch 1 is connected to router 1 through F05 or fast Ethernet 5 in our S1, and it is connected to gigabit Ethernet um, 001 of our router. So for the addressing table, so these are devices R1, S1, and PCA. For the interface, just like what I mentioned earlier, for R1 it's gigabit Ethernet 001, switch 1 is VLAN 1, and PC1 is NIC. So for the IP address for R1 is 192.168.1.1, and switch 1 IP address is 192.168.1.11, and for PCA, IP address is 192.168.1.3. The subnet masks are the same for all the devices, and default gateway is none for router, and um, the same for switch 1 and PCA 192.168 and 1.1. So for the objectives of this experiment, it has 4 parts. The first part is to configure basic device settings. Part 2, configure the router for SSH access. Part 3, configure the switch for SSH access. And Part 4, SSH from CLI on the switch. So background or scenario, in the past, Telnet was the most common network protocol used to remotely configure network devices. Telnet does not encrypt the information between the client and the server. This allows a network sniffer to intercept passwords and configuration information. SSH, or Secure Shell, is a network protocol that establishes a secure terminal emulation connection to a router or other networking devices. SSH encrypts all information that passes over the network link and provides authentication of the remote computer. SSH is rapidly replacing Telnet as a remote login tool of choice for network professionals. SSH is most often used to log in to a remote device and execute commands. However, it can also transfer files using associated secure FTP or SFTP or secure copy SCP protocols. The network devices that are communicating must be configured to support SSH in order for SSH to function. In this lab, you will enable the SSH server on a router and then connect to that router using a PC with an SSH client installed. On a local network, the connection is normally made using Ethernet and IP. So there are some notes here for the routers and our CCNA labs. Okay, and also there are notes here that we need to make sure that the routers and switches have been erased and they have no startup configurations. There. So for the required resources, we would need one router, one switch, one PC, console cables to configure the Cisco iOS devices via the console ports, and Ethernet cables as shown in the topology. So these are not applicable since we're only going to do the experiment in Cisco packet tracer. So now let's head on to our instructions. For part 1, we need to configure basic device settings. So we need to set up the network topology and configure basic settings such as the IP interface IP addresses, device access, passwords, and on the router. So let's do that. Also, we need to cable the network as shown in the topology. So let's first do that. So now we need to cable the network as shown in the topology for step 1. So let's do that. We will need a PC, 2960 switch, and let's use 4331 router. So for the connection, copper straight through, fast Ethernet to switch to fast Ethernet 06, and straight through switch to fast Ethernet 05 to gigabit Ethernet 001, and console. We need to connect console over PC or S2322 router console. There. So next, initialize and reload the router and switch. So to do that, click on PC, desktop, terminal. Okay, so here. Before we edit anything, let's rename the switch before I forget. S1 and the router R2, R1. And now let's initialize and reload the router and switch. So now here, let's enable config D and hostname R1. So now that we have finished configuring our router, let's save the running configuration. Show IP 90 brief, and there. So as you can see, it is unassigned, unset. So um, let's configure again. So let's set 4 gigabit Ethernet 001. Let's put an IP address of 192.168.1.1 and subnet is 255.255.255.0. Next, description R1 IPv4 address and now shutdown. There. So now we need to configure PCA with an IP address and subnet mask. So to do that, let's change this to PCA. As you can see, there is a connection. So we need to go to IP configuration and change the IP address to 192.168.1.3. Subnet is this, and we need to check in our command prompt. We need to verify the network connectivity. So in our command prompt, we need to ping 192.168.1.1. So there's a connection. So next step is to configure the router for SSH access. So using Telnet to connect a network device is a security risk because all the information is transmitted in a clear text format. SSH encrypts the session data and provides device authentication, which is why SSH is the recommended recommended for remote connections. In part 2, you'll configure the router to accept SSH connections over the VTY lines. So let's do that. So for step 1, configure device authentication. The device name and domain are used as a part of the crypto key when it is generated. Therefore, these names must be entered prior to issuing the crypto key command. So first we need to configure the device name, configure the domain for the device. So for us to do that, we need to go on here at Telnet SSH client, and we need to type the IP address, which is 192.168.1.1. Username is admin. Connect. So I forgot, for our IP configuration, we need to change our default gateway to 192.168.1.1. So now that we've changed that, let's ping it again just to check. So there. So now we can continue. We need to configure router for SSH access. So to do that, let's head on back to our terminal, and here R1 config T. So let's use ccna-lab.com, and we need to the device name and domain are used as part of crypto key when generated. So we need to use crypto key generate RSA. So once we type that, it would ask us for the size of the key modulus, and it would tell us our key. So our key is r1.ccna-lab.com. So let's just type 1024 as our bit in the modulus. And now in a username, we need to so in our use 1 2 3 go. So here in a next step, username admin secret. So let's type in the password adm1n capital P at 55. Okay, so there. So now that we have established an SSH connection to the switch, we can check the connection through command prompt. We can type just like what I did here. As you can see, SSH minus L, this is L, not 1, admin 192.168.1.1, and it will ask you for the password. So let me just repeat it. So for example, let me type it again, SSH minus space minus L space admin space 192.168.1.1, and it will ask me for the password. So again, our password is admin, pass with case sensitive characters and numbers and letters. So type on ADM1N capital P at 55. So when I click enter, hit enter rather, warning authorized access only. So when you type enable here, it will ask you for the password. The password is class from what we've set earlier, and we're in our router 1. One more way to check this connection is through here, telnet/SSH client. So we need to type the IP address here 192.168.1.1, and our username is admin. We need to connect, and for the password, the same, capital A, small letter D, M, and 1, and capital P at 55. So they're authorized access only. Now enable and password class, and we're in. So now, for part 3, configure the switch for SSH access, we need to configure the switch to accept SSH connections. After the switch has been configured, establish an SSH session using TerraTerm. So step 1, configure the basic settings on the switch. So we need to go to our switch here, click on CLI, and hit enter. There. And enable config T. Hostname is S1. No IP domain lookup. Enable secret class. Next line console 0. Password is Cisco. Login. Exit. And for the VTY, line VTY 015. Password is Cisco. Login, exit, and for our service password encryption, banner MOTD is warning, authorized access only. And exit. Show IP config. So next we need to configure the switch for SSH connectivity. So let's do that. So this is our info from the table, our IP address. So there. So for configuring the SSH connectivity, the switch for the SSH connectivity, we need to config t. So now we're done. Let's head on to our PC and click on telnet. The same point. Let's first check in our command prompt. SSH exit 12.168.1.11. Username is admin. Password is adm1 npa@55. So there, as you can see, warning, authorized access only. So 192.168.1.11, our IP, and this is our username, admin, capital A, small d, small m, 1, small n, capital P, @55. So there, warning, authorized access only. So enable. Password is class, and we're in our switch 1. So exit. Okay. So for the last part, SSH from CLI on the switch. So the SSH client is built into the Cisco ISO and can be run from the CLI. In part 4, you will SSH to the router from CLI on the switch. So let's do that. So here in our PCA, let's type the host name or IP for our switch, and we'll see if we can connect from our switch to our R1. So let's do that. The IP address on our switch is 192.168.1.11. Username is admin. Connect. Password is still the same. Warning, authorized access only. Enable. So we're going to type the password class. So we could go in our switch. Now that we're in, let's type SSH. SSH space question mark, and we're asked if we're going to log in using this username. So let's type on -l space admin 192.168.1.1, and we're asked for the password. Our password here is our password here is the same, admin, a capital A D M 1 small n p @55. So there, we're in. So next, you can return to switch 1 without closing the SSH session to R1 by pressing Ctrl Shift 6 and release the Ctrl Shift 6 keys and press X. So let's do that. Control Shift 6. Control Shift 6. So there, as you can see, I pressed on Control Shift 6 and I pressed X and it's back to S1. So to return to the SSH session on R1, press enter on a blank CLI line. So here, so there, resuming connection to 192.168.1.1 and enter a second time to see the router CLI prompt. So there, as you can see, we're back to R1. So lastly, to end the SSH connection on R1, type exit on the router prompt. And there. So what versions of SSH are supported from the CLI? So let's type SSH V. So what versions of SSH are supported from the CLI? We have one protocol version 1 and protocol version 2. There. So our reflection question, how would you provide multiple users, each with their own username, access to a network device? So with the results of our experiment, we can therefore conclude that we can provide multiple users by adding each of the user's username and password to the local database using the username command. So they can access they can access the device using multiple user. So multiple users can access the device.